Assalamualaikum students, how are you? Hello everyone. Okay, that question is very, very important, and that question belongs to the summer 24, the latest paper, and it fits for to the question number 7 of the M1. The first part is two particles P and Q, the mass is 2.5 kg and 0.5 kg respectively, are connected as a light inextensible string. The passes over a smooth pulley fixed at the top of the plane, inclined at an angle of 30 degrees to the horizontal. P is on the plane and the Q hangs below the pulley. Aside that, the level of the Q and the P is 2 meters below the P. Release from rest. Okay. And when the particle moves release from rest, we have to find the acceleration of the particle. The second sentence is very important over here. Just I will read this one. Particle is released from rest with the string taut and the slides down. That is very, very important. The particle is P moving slide down. If the particle P is moving slide down, that is the direction of this particle. And the particle will move in this direction, if I'm not wrong. And this particle Q will move in upward direction. No, I have to make the force diagram of all these situations. What are the force diagram? Both the particles are moving with the constant acceleration. I suppose that the constant acceleration is a meter per second square. And the constant acceleration of this one is also a meter per second square. Now, because both the particles are attached with the string and string is passing over a frictionless pulley, so the particle Q will experience the force of the tension away from the Q. That is called the T, because this is a one string and the string is the same. So there will be tension on the P away from the P is just like this one. Now I have to move for the force diagram of this particle. The force diagram will be just like this one. I will make with the help of a red. So the first one, that is called the normal reaction, because when a body is contact with this one, when a body has a mass, its weight is always downward, and this is the weight of the mass is always downward. Now I have to write this one as well. I have to make the components of this force. The force is P. So, sorry, beta. So over here, we have to make the force diagram. So I will break this one. The force is 10 is the force of the weight is breakup. Or so that's the components of these forces. We know that the angle between the plane and the weight is always equal. So that angle will also be of 30 degree. That is called the normal reaction. And the mu we have that is 0.2. That's the value of mu. Now we have to write, we have to find the equation. So particle Q is moving upward. So first of all, I will make the equation of Q. So what should be the equation of Q? That is very simple. Equation of Q. That would be is equal to the, if I will make the equation of Q, that will is equal to the T forward force minus backward force. What is the weight of this one is that is 5 Newton. Similarly, but the weight of this one is 25 Newton. So this component, I will make the components over here. Sorry, I will make the components with the help of the, suppose, a blue color. So this component, this angle to opposite that becomes 25 sine of 30 degree if I'm not wrong. That component is 25 cos of 30 degree. So the particle Q, we have this T minus for opposite forces 5 is equal to the MA. Mass of the particle Q is 0.5 and A will as it is. Now you have to make the equation of P. There are two equations of P. When we equalize the terms, I will get this one. So equation of I have to write equation of P. So first of all, the normal reaction is equal to the 25 times cos of 30 degree. Am I right? That will be equal to the, if I'm not wrong, I have used to calculator. So that will be equal to the, wait a minute. I have this one is over here on this side. So that will be is equal to the 25 cos of 30 degree. I have to write this one as 25 multiplied by cos of 30 degree. So I will find over here, the answer will be in decimals. I will have done 21.65 if I'm not wrong, 21.65. So that's the value of 21.650. That's the value of R, that is Newton. R is a force. The second equation I have to make by this one with the help of a different color. Suppose the color is now green, and green color means a forward force. But the forward force is this one, 25 sine of 30 degree forward force, and the backward force is T, and another backward force is mu R. Why mu R? Because the particle is moving downwards. So other forces, that first force is 25 sine of 30 degree, if I'm not wrong. That is the forward force minus T, backward force minus mu R. Mu times R is equal to the MA. 2.5 is the mass of the particle P, and acceleration is the common, that is A over here. So 25, I have this one is put the values of over here. I will get what are the values. 25 cos sine of 30 degree becomes 12.5. Use your calculator. That becomes 12.5 minus T. New answer is 0.2 multiplied by 21.650. If I'm not wrong, that is equal to the 2.5A. That is equal to the 2.5A. Okay, now I have to use the calculator to find the answer of this one. The whole 12.5. I make it clear. I will use the calculator. So all clear. The first of all, I have to write 12.5. That is 12.5 minus, then I have 0.2. 0.2 multiplied by 21.650. Multiplied by 21.650. So what's the answer of this one is? Answer is always positive over here, 8.17. So I have the answer of this one is 8.17. 17 minus T is equal to the 2.5A, if I'm not wrong. Now I have to solve both the equations simultaneously. The first equation is this one, if I'm not wrong. The second equation is this one, if I'm not wrong. So that is the equation number 1, and that's the equation number 2. So I have this is equation number 1. So I will use this color now. That is called equation number 1, and that is called equation number 2. If I'm not wrong, I have to solve both the equation. There are 4 different methods to solve this type of the equation. One of the method is the substitutions method. The value of T you have to find from here and put over here. Okay, what's the value of T? Well, we find from here. The value of T is over here. That becomes T on other side. T is equal to, that becomes on the other side, it becomes over here 8.17 minus 2.5. You have to substitute the value in equation number 1. So we will get the 8.17 minus 2.5A minus 5 is equal to the 0.5 A. If I'm not wrong, then we have this one. So shift the terms of the one side and other terms on the other side. So 8.17 minus 5, it becomes 3.17. And when you add 2.5 and 0.5, it becomes 3 times A. So the value of A, you have to use the calculator a lot. You have to use the calculator a lot. 3.17 divided by 3. If I'm not wrong, answer will be this one. What will be the answer is this one, 1.056. So answer will be this one, 1 point, that is 0.56, 0.56. But in the final exams, you have to write answer of the angle is always in 1 decimal places, and other angles you have to write up to 2 decimal places. So you have the 0.6, 1.06. That's the value of this one. That is the first part of the question. Now I have to solve the second part of the question. And what will the second part? You have to consider this one. I will erase this one and read the statement of the question step by step. First of all, I have to erase the whole things. Erase this one. Then we have to move the second one over here. That's the second part of the question. Use energy method to find the speed of the particle at the instant when they are at the same vertical height. When they are at the same vertical height, I have to draw the figure by myself so that you can understand the things. Suppose the figure is just like this one. That is the portion over here. And that's the portion of this inclined plane. And bodies over here, there are two bodies, and two bodies are over here. The first is placed on this body at this one, at this place is over here. That is called the pulley, and pulley will have the blank circles. Pulley will be over here. And then we have the second particle. The second particle is below. Where is the second particle? It's below, exactly over here. Suppose that that is the point over here. Okay, I will erase this one and I will extend this line up to over here. So that line will be moved up to over here. And so that line is this one. That is inclined plane. So that angle is given, that angle is 30 degree. Am I right? Now the string are attached with them. So the first string is over here. The second string is attached with this one over here. And the distance between these 2 points, distance between these 2 points is this one. The first distance is this one. According to the state, the vertical difference is between these two is 2 meters. That distance is given, a statement of the question, that is 2 meters. The distance between their vertical height is 2 meters. Now that particle is 2.5. That particle is P, that particle is Q. Now, when the particle moves and at a certain height, what will happen? Certain vertical height, what will happen is this one. Suppose this particle will reach over here. It's green color. Okay, a particle will be reach over here. This green, I have to write with the green color over here. If I'm not wrong, I have to put green color. So not red, I have to put green color over here. So that's the green color. So the particle vertical will have this one, that particle over here. So that particle will be over here. At this state, their vertical height will be same. Their vertical height will be same. So that's a very important thing. If that distance is this distance, we have no information about this distance. That distance is x. So this distance also will be x because both the bodies are connecting with each other. So the green color shows the latest position, and this one is shows the um, pink color shows the initial condition. Now over here, this distance is equal to x. That distance is equal to the x, and that distance is equal to the x. Now we have to make a triangle, because we have to find the vertical height to find the potential energy. We have to find the vertical height. So I have to change this one. I will make it suppose the red one. So I have this is the triangle. That is called the right angle triangle. Am I right? If this is a right angle triangle, this angle is 30. This angle is also 30 degrees. So now whenever we have the right angle triangle, we have the opposite and perpendicular sides. So I have this one is this height 30x, that becomes x times sine of 30 degrees. Am I right? Okay, now these two heights are same. Suppose we have these two heights are same, because this one and this one, these two heights are same. So these two heights are same. This means that will be equal to be also x. First of all, I will try to find what's the value of x. The value of x is over here, because this x plus x 30. So x plus this height, and this height. So x plus x times sine of 30 degree, that becomes is equal to 2. So x plus sine 30 is 1 by 2. So 1 by 2x is equal to 2. So you have to use the calculator. I will get the x is 4 by 3 if I'm not wrong. So now I will draw the force diagram. What is the force diagram? Because there is no driving force. There is no driving force. So the particle, what will happen? When the particle is connected, this one, the tension is over here. Upper direction, the tension is over here, that is in this direction. But the surface is rough, so we have another value that is called mu times r. The particle is moving, mu times r. Now over here, the normal reaction and all these things, I will draw another figure over here to find the forces upon this one. Work power energy formula is that work done by driving force minus work done by opposing force or the resistance is equal to the change in kinetic energy plus change in potential energy. So we have to find all these things step by step. So the first one is the work done by driving force. So first of all, there are two driving force. The first driving force is on the body is on this body is T times body Q. So T times the distance X is, so work done by on Q. The first one is work done by driving force. Driving force of particle Q. So what will be particle Q, if I'm not wrong? That is T is applying force, T into the distance is covered by this one, driving force is only X. So Tx is the driving force. But remember that on this particle P, there is no driving force. The particle is moving towards, due to the component of the weight. And we know that the component of the weight is not an external force. Okay, now I have to find the work done by resistance. So work done by resistance. Beta, over here, there are two resistance for the mu r. The second one is T. So T plus mu r times X, if I'm not wrong. Okay, next one is I have to find the change in kinetic energy. So change in kinetic energy is equal to the final energy. Final energy after this one, when their heights, vertical heights are same. So after that time, the bodies are connected with the same velocity. So 1 by 2, the first particle is P, it is 2.5 and V square, and plus final velocity will be this one also, 1 by 2 into 0.5 into V square, minus before starting at the initial stage when the particles hold at when we particle hold in this position. So the initial velocity will be 0, of particle P and 0 as particle Q. So when I solve this one, half 2.5 into 1 2.5, when you use your calculator, the answer will be 3 by 2 V square. If I'm not wrong, 1.5 V square. Okay, now I have to find the change in potential energy. So final potential energy means when the particle is at green color positions. Both the particles are green color positions. So we have this one is, first of all, the potential energy at green color position of the P and Q. The Q will be, what is the Q will be? mgh. M is the mass of the Q, that is 0.5 if I'm not wrong. G as it is, and the height of this particle is x. Very good. Plus, the second thing is, I have to find the final position of the particle Q over here, particle P over here, after that covering a distance of x along the plane. So I have its height is again x. And that is a reference line. Reference line is that line which is the least level of the motion. So that will also is equal to the mgh. M means the mass, that is 2.5. G will as it is, and height in this case is x, this one, minus their initial potential energy. Potential energy of the particle Q is equal to 0 initial, and minus this one that is equal to total height from this level of this one is total 2. Already given statement of the question is 2. I have the M. M is 2.5 into G as it is into height is 2, if I'm not wrong. So that is the total kinetic energy, 2.0.5, 2.5, and I have this one is 2. So what will be this one? 0.5 and 2.5 becomes 3gx. Am I right? And this becomes minus, that becomes, it becomes 3gx, and that becomes 2 multiplied by 2.5 becomes the 5g. No, I have the value of x over here, and I will substitute the values of x. These four things I have to substitute in original question. I have to substitute in original question. Before starting, I have to use the result of the previous one. What are the result of the previous one? The result of the previous one is R. R is equal to the, that is equal to M times mg cos of 30 degree. Already we have the force diagram with the previous one. M means 2.5, G as it is, and cos 30 means root 3 by 2. And mu, the value mu of already given, the last part is 0.2. So we have this, you use the whole equation. This is the first value, they change our potential energy over here. This one is, that is the potential energy, and this one is the kinetic energy change, that is the over thing. All these things I will get and put the values over here step by step. Don't be panic. Okay, now I have to remove this whole figure because I have to use the calculator, and for calculator I have this one is x is 4 by 3. B, remember the things. So first of all, I have to write work done by driving force minus work done by resistance is equal to the change in kinetic energy and plus change in potential energy. If I'm not taught, work done by driving force is already given. What's the work done by driving force is T times X, because there is only the driving force, the external force is on the particle Q, and there is no external force over it. That is T times X minus work done by resistance. Work done by resistance. Resistance is this one, 2.5, if I'm not wrong, G as it is, if I'm not wrong, root 3 by 2 as it is. Times, that is the resistance. Resistance multiplied by distance, that distance is X. Okay, sorry, the total resistance is not over here. The total resistance is this one, if I'm not wrong. The total resistance is T plus mu R. T plus mu R times X is equal to the change in kinetic energy 1.5 V square plus change in potential energy 3gx, and minus 5g, if I'm not wrong. So tx, and I will expand this bracket, tx minus mu times r times x is equal to the 1.5 v square plus 3 times gx minus 5g. Now I have to use the color or will put different. Suppose this one, these two terms will be cancel out, minus and minus. Value of the mu is this one, that is 0.2. The value of R is mg. That becomes 2.5. G means 10 and root 3 by 2. Mu times R, that's a negative sign, is equal to the 1.5 v square plus 3g. The value of x is 4 by 3. I have already this one, that is 5g. This 3 is cancelled by this one. No, I have this one is 5g. It becomes g because plus 4g and minus 5g, plus 4g and minus 5g becomes minus g, and minus g it becomes plus g. You have the 0.2 multiply by 2.5 multiply by 10 root 3 by 2 is equal to the 1.5 v square. I have to find the value of v from here. So I have to use the calculator a lot. I have to use the calculator a lot. What will be the over here? The g is 10 minus 0.2 into 2.5 into 10 root 3 by 2 divided by 1.5 whole under root. That's the value of v. Now I have to use the calculator a lot, this one. So I will make it all clear. First of all, I have to write 10 and minus 0.2. The first value multiply by 2.5. The second value multiply by the 10. Multiply by 10. Multiply by cos of 30 degree. If I'm not wrong, that becomes cos of 30 degree. This one, this value already root 3 by 2. What's the answer of this one is? We have this answer in the decimal is this one. So divided by, it will, if so, please check if there is something mistake, divided by 1.5. I have this answer, that will be this one, 3.771. Take the square root of this number. So I will get to 1.94420. A little bit to read. I think if something is wrong, please check it, but the method is this one. The method will be this one. The value of R is m times g times cos of 30 degree. Please check this one. And mu R is 0.2, 1.5. That becomes the minus 10, 1.5. So you have all these values, if I'm not wrong. 0.2, okay. I have to multiply by this one, sorry. That's the value I have to multiply. Haven't I multiplied by this one because x is also, I just forgot this one. That's this one, the resistance, and resistance is multiply with 1 by 4 by 3. So I have to solve this one as, if I'm not wrong, please, I have to multiply by this one. I have to multiply over here. This term will multiply by 4 by 3. Now you will get the answer. Then you will get the correct answer. Again, I will try to simplify all clear. So it becomes all clear. Now I have to write the 10. The first one is minus 0.2, if I'm not wrong, multiply by 2.5, if I'm not wrong, multiply by 10, the value of g, if I'm not wrong, multiply by the cos of 30 degree, if I'm not wrong, then multiply by a fraction is 4 by 3, so 1.333. So I have to this answer. Am I right? Divided by, so I have to write this one, if I'm not wrong, 4.2279 divided by 1.5. that is equal to V. So I have to divide it by where is the sign of division? Divided by 1.5. Okay, I have this one, 2.81. I have to take the square root of this answer. I will get 1.67. Okay, 1.6788. That's the value of V. Boys and girls and students, please remember that the final answer in the Cambridge University is two decimal places. So 1.68 meter per second will be the velocity when both the particles P and Q will be at the same height. Thank you, beta. Well done. Allah Hafiz.